Hi everyone, let's talk about higher order derivatives. It's pretty simple if you already understand the derivative. So here the second derivative, you could ignore this one. Later we would learn the partial differentiation. So the notation is, you see first order, so f prime or y prime or dy dx, and you could f of x dx. So the second is based on the first order, so first derivative, then I one more prime. Then is, we say single quotation is prime, then another one, so quotation mark, or you say double quotation mark, this is second order derivative. Or your y prime and another prime, so second order. Or we could just, for the 2 there, the square here, and the same thing for the f of x. So that's the second order derivative. So if a higher order, suppose the third order derivative, first order, second order, third order. Or you just f also the third derivative, right? Then you get the cube here. So you get all those notations exactly same. Sometimes, for that we could just directly write this quotation mark. You don't need a parenthesis of x, We know that's the second order derivative. So for the notations, we know first order derivative, second, and the third. But suppose more than 3, go to the top, the exponent location, the parenthesis 4. So for the f of x, so you do that. So we know that's the first order derivative, like fifths, right? Or nths. That's why you have to use the parentheses, otherwise become really exponent y to the nth power. Now you have this parentheses. So we could do the summary, so first order, right? You could do just one, or dy dx, second one, and this is a square here, then here. Or the third one, you could do this parentheses, then 3. The first, you no longer do the quotation mark. Of course, if your y could replace by f of x, because y is a function of x. So you can keep going, nths, right? Nths. Or you could add one more, this is f. Or you could just f, or you could put the parentheses x, right? Is the second order, third order, and the first order, nth order. Now let's do the examples. So you just do one derivative at a time. So first we start the first order derivative. If you are fast, you don't need this step, right? You can directly go to the next step. So 4 jump down. We first use the addition rule, then work on that and this term and this term. So the first is 4 jump down, then 4 minus 1, this exponent, the x cubed, then minus 3, then times this 2 jump down is 6, right? Then this 2 minus 1 is just 1. And minus 2, the negative jump down, x is negative 2 minus 1 is negative 3. So that's the first derivative. Then let's do the second one. Second one, you just based on the first derivative, the function, then you do the derivative. So now is 12, right? 3 get down, then x and 2, then minus 6 plus minus 2, then negative 3 get down, then negative 3 minus 1. So 12x squared minus 6, here is plus 6x to the power of negative 4. Or you could write your answer is 12x squared minus 6 plus 6 over x to the power of 4. Okay, so the next question is the same steps. So let's get to the first order. Let's do a little bit quick. So 3 jump down, 9, x squared minus 4 times 2 is 8. Then downgrade 1, right? Because x squared become x, then plus 0. Now the second order derivative here is 18x minus 8. because here 2 jump down 18, then downgrade 1, minus 1. Here is just 8. Okay, now let's do another example. So first question asks how fast is f of x changing? That means f prime, the first order derivative. So now here is f prime, the derivative changing. That means the second order, right? Then at this point, when x equal 1, that means f prime 1 equals that, right? Second order. First derivative is, 12x cubed. The second is 6 times 3, right? 18. x3 is minus 1, 2, right? Square. Then 6x. Then the second order is 36x squared plus 36x minus 6. The first derivative is this function, and you replace x equal 1. So it's 12 plus 18 minus 6, right? It's 24. So the second here, the derivative is here. So 36x squared plus 36x minus 6 when x equal 1. So 36 plus 36 minus 6 is 66. And here, 110 is a point on this graph f of x. So actually, I don't need to give you this 10. I don't need it because when x equal 1, what's y? That means x replaced by 1, right? So you put here, x is 1. So 3 plus 6 minus 3 plus 4 is actually 10. So if I say at a point 110, exactly means at a point x equal 1. You could say at a point 110 or at a point x equals 1. And I also have one more. Here, ask you f prime x is increasing or decreasing. So because we want to know this one, so we need to, based on this one, this is a function, right? Based on this function's derivative, that is second derivative. So if this is greater than 0, we say it's increasing. If less than 0, it's decreasing. If equal 0, no changing, just flat, horizontally, right? This tangent line is horizontally. The slope is 0. Here it means the slope, because the derivative, right? Derivative is slope. That means at that point, the slope greater than 0 is increasing, less than 0 is decreasing. So here, let's see, you see here, we got 66 greater than 0, so we know it's increasing.